Hi, in this lesson we look at an example where we're told a rectangular garden has a diagonal length of 13 meters. If the perimeter of the garden is 34 meters, what are the dimensions of the garden? So the first thing that I do when I'm solving word problems is, especially if they involve geometries or an object or something, I generally try to draw a diagram. So let's start off by drawing a diagram in this case. So we're told a rectangular garden has a diagonal length of 13 meters. So let's draw that out. Let's draw out this rectangular garden. Then we're told, we're told that it has a diagonal length of 13 meters. So let's draw the diagonal. So we know that this length here is 13 meters. We know that the perimeter of the garden is 34 meters, so let's figure out some ways so that we can piece together this information. So next thing I'm going to look at is, what am I asked to solve in this problem? And the question actually asks us to figure out the dimensions of the garden. So I don't know what the dimensions of the garden are, so let's just introduce some variables, x and y. So let's say let x represent the width, and and y the length. The length of the garden in meters. Because we're dealing with meters here, so x and y are in meters. So one piece of information that we know is that we're told that the perimeter is 34 meters. So we know that x plus y times 2 should be equal to 34. That's because if I add x plus y and then I double that, that'll be equal to the perimeter. I can make this equation a little bit simpler by dividing both sides by 2. So I get that x plus y is equal to 17. Now I also know that this figure is a rectangle. So that means that all of the interior angles are 90 degrees, meaning all the interior angles of the rectangle. So that angle, this angle, and this angle is 90 degrees. Now, if I take this point, and this point, I have a triangle. So I know that since this is a 90-degree angle, that this triangle here is a right angle triangle. So I can use the Pythagorean Theorem. I know that x squared plus y squared is going to be equal to 13 squared. Or x squared plus y squared is equal to 169. So if I rewrite this equation, I can rewrite y in terms of x, so I get that y is equal to 17 minus x. And I can sub 17 minus x for y in x squared plus y squared is equal to 169. If I do that, I get x squared plus bracket 17 minus x. Oops, let me rewrite that a little bit nicer. X squared plus 17 minus x squared should be equal to 169. So all that I've done in this case is I've just replaced y with 17 minus x. So I replaced y with 17 minus x. And now I've got an equation in terms of a single variable. And I can simplify this and write it in standard form and then try to solve it. So if I do that, I get x squared plus x squared minus 34x plus 289 is equal to 169. I got this from just squaring 17 minus x. I can subtract 169 from both sides and combine some like terms. So I get, if I add x squared plus x squared, I get 2x squared minus 34x. 289 minus 169 is just positive 120. Now, I've got this written in standard form. I can factor it by first identifying that there's a common factor between all three terms. The common factor is 2. So I can write this as 2 times x squared minus 17x plus 60. And that's equal to 0. So I can factor this by saying what two numbers multiply to 60 and add to negative 17, because the coefficient on x squared is 1. So the two numbers that multiply to 60 and add to negative 17 are negative 12 and negative 5. So the solutions to this equation are x is equal to 12 and x is equal to 5. So if x is equal to 12, y is equal to 17 minus 12, which is 5. If y is equal to 5, if x is equal to 5, well then y would be equal to 17 minus 5, which is equal to 12. So either the dimensions are 12 and 5 or 5 and 12. So that means that a rectangular is the same when you rotate it. So that means the dimensions are just going to be 5 meters by 12 meters. So let's say, therefore, the dimensions are 5 meters by 12 meters. So that concludes this lesson, and we'll see you in the next video.